There can be many things said about the My Maven's channel. Some of them justified, some not justified, but nobody can argue that I don't mix it up. As soon as I heard about this item, I thought, yep, that's perfect for one of my videos. So I was contacted by a viewer and Patreon called Liam, and he works at a school in London, and basically they had a flood in the basement. Hence the reason that box there is all flood damage. I can see that. You can just see that's exactly what happens when cardboard goes wet and then dries out. So it's a snow machine. He left it, I think, for a year and a half or a couple of years, went to plug it in and it tripped the electrics. And so he thought, okay. He contacted me and I thought, yep, that'd be perfect for a video. I gave him a £50 donation to put towards another snow machine for the school, because there's no way I would fix something and put it back into an environment like a school, because obviously if something went wrong, it could be disastrous. So yeah, let's take a look at this and let's see if it can be fixed. I'm not going to plug it in because I know it's been water damaged and I know that it's already tripped the electrics. So obviously there's a short somewhere. I want to find out where that is and if it can be fixed. And then at the end, let's see if we can get any snow out of this snow machine. Now, it's not real snow. This is one of these machines that cost around about £150 new, and they pump foam into the air. So it's like snow effect, but it's supposed to look pretty good. So yeah, it's huge, it's heavy. He's also given me some snow liquid in here as well. Let's take it out, take it apart and see if we can get this thing working again. Well, it's a bit on the large side for the blue mat. This thing here plugs into the back, and it looks like this is how you can adjust how much output it's, how much snow it throws out. So now let's take this out. This is the fluid. And we'll put it to one side. Well, I can definitely see some rust and stuff down here. So I suppose we'll just undo all these screws around the edge. And I mean, this is all made out of metal, so hopefully then it will lift off and we can see what's going on in the on the inside. Right, is this all going to lift off? Yes, it is. Oh, I've got to, is this going to unplug from somewhere? So let's see, is that just going to, or is it cable tied on? Yes, okay, it's come off. Oh, just leaked out all over my trousers. Nice. Looks like I wet myself. Okay, now what do we have here? Let's turn it around this way. Right, we've got this thing here, which is going to be some kind of turbine-y thing, which is going to, so basically this is just going to be a massive motor on a fan, isn't it? Pushing air through this here. And we know that the fluid that was in the bottle here, the snow fluid, goes through this thing here. So this is going to be some sort of little pump that pumps it into here. So that side of it looks quite straightforward. Something's shorting, isn't it? Because otherwise it wouldn't have tripped the breaker. So should we go straight onto the contacts here and see what it's doing? Is that going to be strong enough to hold? Yeah. Oh, we have a level here to show how full and empty the little tank is. Right, let's see what's going on here. So we go between live and neutral. Mm, 1000 ohm shorts. Not sure if that is actually a fault or not. Let's go between, not sure if that's going to be neutral or live, but anyway, let's go between that and earth. Nothing. Nothing. And are we earthed? Yeah, 5 ohms, so we're earthed to the chassis. Okay, initially, I can't see why we can't plug this in. Dip switch, I mean, I don't know what the dip switches are about.
maybe we should take the board out and have a look at the board before we go anywhere. Because from here, from the switch it goes into here. Sorry, from the input it goes into here, and then from the switch it goes into the board. So this is the input here, and then from there it goes off to the motor here. I wonder, could there be a problem with the motor? Tell you what, let's unplug it from here if we can. Is that going to be easy? Yes. Brown to brown, blue to blue. Let's see what the, mind you, I don't know what the motor's supposed to be reading. Let me see if there's anything on the motor. No, there's nothing there going into the motor. We've got two things here. Where do they go to? Ah, hold on now. That's not right. The pump's been disconnected. The pump's been disconnected, and also there was a screw missing, and it looked like a bigger screw was pumped in. Maybe that's normal, but there was a bigger screw pumped into one of the front ones. You know, like a self-tapper rather than the machine. Right, so it looks then that maybe the pump's been disconnected for a reason. Maybe it was the pump that put the short on. Let's have a look here. Doesn't seem to be anything on that. There's no direct short there to cause a problem, but maybe when it's energized. Right, I think we should plug it back in, but I'm not going to know which way it's going to suck, and because I don't know which one was negative and which one was positive. So one way it might be sucking and one way it might be blow. You know, like we need it to suck this side and blow this side, don't we? But I might put it on the other way. I think to begin with, let's plug it in without this and see what it does. And then I think we'll plug it in with that and see what it does. I'm just going to get one of these leads. Actually, before plugging it in, let's have a look at the back of here, just to see if there's any scorch or burn marks. I'm thinking now water's got into a part of this that it shouldn't have gone into, because this is the lowest component down. I mean, there's nothing else down here to fail. So I think that's what I think this now is the problem, and that's the reason it's been disconnected. Because maybe when that's connected, it shorts the fuse board, you know, the customer consumer unit. Let's have a look at the back of this. Right, tiny. It looks a little bit different on these pins here, but I don't think that is anything. That looks perfect. I can't see that there's any problems there at all. Right, let's pop that back on. Maybe we should look at this before we put power into it. See if we can see corrosion on the inside, because then if we can clean it out, then we might just fix the problem. Unplug that there. Just going to cut these cable ties. So I snipped the cable ties, and then there's two screws holding this little pump in at the bottom, so I undo them. The reason I'm getting to this pump is because it's been disconnected. Why has it been disconnected? Also, we know, looking at the cardboard box, that this looks like it's been flooded up to about 4 or 5 inches, so this would have been completely submerged in the flood. That's the reason I'm thinking this is faulty. I'm hoping to open it up and find it full of corrosion, and maybe this is where it's shorted out, because we've got water, and water's going to conduct and put it to the earth of the actual casing. Annoyingly, this is, remember, this is for the snow fluid that goes through it. Now, this is encased in, and it's kind of folded round, so there's no easy way to get into it. I'm having to use a screwdriver, and I'm prising it all the way around the edge to try to get it open. I'm kind of like opening up where it's been flanged over. Anyway, eventually I do get it, and I get access to the inside. Annoyingly, it's all looking pretty good. I don't want to mess with the mechanical side of it, because I presume that might be okay. I want to look at the electrical side. So I want to get to this coil, but then when I measure the wires, it's giving me a weird reading. It's in the megohms, but I notice there's a little heat shrink on it. So I cut open the heat shrink, and inside that, there's a little diode. Now, I'm not really sure what that's there for. I know this is AC, so is it only to make it work one way round? Anyway, I test the diode on diode mode and it's all testing okay. I've got to read in one way and not the other way. But when I go between the red lead and the other side of the diode, I am now getting a reading. So that means the coil is okay, but I visually want to check it. I look at the coil and to me, it looks okay. There's continuity and there's no damage there. It all looks all right. I can see corrosion inside the casing, but the coil itself looks okay and it's not wet anymore. That corrosion is now old. So annoyingly, I don't actually think this is faulty. So what I need to do is I need to put it all back together, which is going to take a little bit of time. To get it back together, I have to use a hammer and I have to tap the casing back around in on itself and use a screwdriver to help me on some of the bits. But it's okay, it goes in okay. I think it's pretty much as good as it was to begin with, so I'm relatively happy with how that went, but annoyingly I didn't need to go in it at all. I'm just going to pop a heat shrink on it just to get it all nice and safe again, because this was heat shrinked originally over the diode. So that's it. I don't think there's anything wrong with the pump, but I'm glad we looked at it because that was the most likely thing that was going to be faulty. So now we need to look at something else. Right, so I'm going to put this back together and cable tie it back in with the wires, and then we'll turn it on and we'll see what it does. So while we're putting it back together, we'll give a shout out to the My Mate Vince Massive. And the members this month are KipDigital.com, Kip Hakes, Max Rokotansky, Having Fun Repairs, Will Michaelis, Chris Seal, Felipe at MrKeebs.com, DJVG, Pigsy, Robert from Timsy's Auto Air, Daniel Watson, Zeeks C, Anthony Dean, Bazza2, Operational 117, Russ Melanson, Ellis Garbett, and Gaspar Heller. Massive thanks, guys. Right now, I'm not sure what these thinner wires are, but just in case they're low voltage, I haven't cable tied these high voltage ones to the low voltage ones here. So they're all separate. Right, let's get the cover back on for safety in case it does go bang in my face. I'm going to plug it in and I'm going to plug it into my isolation transformer. Just in case something was to happen where this was to become live, I'd rather it be through the isolation transformer. So it is at the moment off. I'm going to plug it in now. Right, okay. We're plugged in. So far there's no bang. I'm going to turn it on now, but I'm very, very wary. Oh, here we go. Now, what was that? What did that mean? It sort of came on and then, let's do that again. Oh, here we go. No, that doesn't sound right, does it? I wonder, has that blown something? Yeah, my isolation transformer's gone off. What's that about then? Now, many times in this video, my isolation transformer gets tripped. During filming, I'm wondering, is it because that's what the fault is on the machine? Because remember, Liam told me that it tripped the electrics. But I'll show you at the end of the video. Basically, my isolation transformer is rated 240 volts at 400 watts on the output. This Snow machine is 1200 watts, so you would expect it to trip something which is rated for 400 watts because it's drawing too much. But you need to remember, at the time of filming, I didn't know that until later on in the video, so it's kind of quite confusing. You know, is it tripping because it's just supposed to trip because it's 400 watts and this is 1200 watts, or is it tripping because there's a fault on the machine? For someone like me, this particular attempted fix is very taxing because it just seems, you know, like wires are disconnected, so it makes you think the pump's failed. But then, as far as I can see, the pump looks okay. Having not owned one of these machines before, I don't really know how it's supposed to work. Yeah, so I'm well out of my depth on this one. But anyway, it did make a bit of a noise when we turned it on there, but yet when we tested the fan earlier for continuity at the beginning of the video, my meter was open. So I think we need to have a look at the fan to see if we can see anything obvious on the inside of that, because as far as I can see, the pump looks like it's okay. So to get to the fan, all we have to do is undo 4 screws from the bottom, and that releases the fan unit. To get into the fan, there's a load of nut and bolts going right the way around the circumference on it. Everything on this thing is super easy to get to, really accessible, loads of room to work. It's an absolute joy to work on. As well as that, it looks like it's been made with repair in mind. For example, even the nut and bolts going through, I don't even need a spanner on one side, because the way the plastic's been formed, there's little lips coming out of it, little pillars coming out that trap the nuts. So you can just use a screwdriver to undo the screw or the bolt, and the nut stays in place there. It doesn't keep spinning. And also, it doesn't matter which way around you put the nut and bolt, because these pillars are on both sides. So everything's been designed to be easy to get to, easy to repair. Really, really nice to work on. Anyway, let's open up this fan and see what's on the inside. Okay, what we got going on here? Wow, bit of rust down the bottom of that. Now this might be more likely as the faulty thing. Ugh, look at it all. Hope it's not a sewer leak. Now, let's get some slack. Yeah, look at that. So maybe there was nothing wrong with that little pump at all. Oh yeah, look at the way that's done there with a little filter on it. Can you see? Yeah, I wonder. Yeah, I don't know what sort of filter that is. It's kind of hard. Okay, well hopefully that's all working. Right, so I think it looks more likely that the motor is at fault because of all this stuff here. Look, that's it. Right, I'm going to wash my hands, I'm going to pop some gloves on. Also, I need to change my memory card over, and then we'll have a look here. I think that this motor is seized, and that's what's causing the problem. Let's unplug it from here. And here. I just want to go to continuity, and I just want to see if the wires look okay going into here. Right, so they're going okay to there. That's going okay to here. Fine. Which is going to this one over here, this light brush. So now let's go on to the live. So that's going to be going over here. So that's okay. Right, so that's going on to the middle bit here. So we've definitely got continuity there. Now, let's see if we've got that on the neutral as well. The neutral is going to be this one here, isn't it? But we haven't got that on the... We don't seem to have that on the neutral. Wait a minute. Right, okay, I've zoomed out a little bit so you can see. I've taken my meter off the beep test, and now it's just going to read for continuity, because my meter will only beep under 50 ohms. So you think you haven't got continuity, but actually you have. So basically we have these brushes here from the neutral and the live going on to the middle bit of the motor. And if you have a look, if I go onto the live one here, and if I go onto the middle bit of the motor, you can see that we are getting a reading. Yeah, 5 ohms, so that would actually be beeping. But now look, if I do the same thing on the neutral, we're not getting a reading. See? Okay, we're getting a reading there now. But see, it's in the thousands of ohms. There's a problem with that neutral brush, I think. Yeah, there's a problem, because look, if I go here now, you will see that we will have like a direct short. See, direct short, less than 1 ohm. But yet, when we go on to the actual, and if I go onto this thing here, you can see that we have a direct short near enough. But when we go onto the middle bit, it's like 71. Now we're in the meg ohms. It's not there. So we've got a problem, I think, with the neutral brush going into the middle. but not the live one. So we need to somehow take that out, which I presume we're going to be doing from here. Let's give it a go. Let's see if I can force these things out or not. I wonder if I was just to spin it loads, would it clean itself up? Maybe. But let's see if we can actually pop it out. You never know. Is this going to now pop out or not? Yes, it is. Whoa, here we go. Oh, look at all that rust. Okay, come on now. Come all the way out. Are you going to come out or are you stuck? Let's try to give it a little turn to help it. No, it's not coming out. It's just jammed. So what's happened is it's seized up in here, so it's no longer hitting against this middle thing. Yeah, you see this middle thing in here. Armature or something. Apologies, I don't know all the terminologies, but that's what's happening. This has got seized up in here. We need to be able to free this up. So as it wears, the spring will push it down more. So right now it's lodged. You know what? I'm going to take off this one as well, because I mean you can see this one is more rusty than this side here. I just want to see, is this side free? And let's see if this will pop out. There you go. This is much cleaner. There you go. There you go. Right, so that's come out lovely, hasn't it? So that we need to free up the other side. Okay, I've really enjoyed this video, even if I can't get it working at the end, because let's face it, I don't know. You can buy this unit for £150. I've got a feeling buying one of these is probably going to be close to that price. But as long as we found what the problem was, that's the main thing. So let's shove this side back in now. So look, now that that's loose, we're not going to have continuity between here and this middle bit because it's loose, and that's what's happened on the other side. So again, if I go to here now and go to live, let's just see what it's reading. Right, going into the middle now. Is it reading anything? No. Yep. And now when I push this all the way in, it should hopefully start reading something. I wonder, is that enough? Yeah, there you go. Excellent! We found what the problem is. Fantastic. Oh, happy about that. Right, let's pop this back in.
Well, isn't that fantastic? A seized brush on the neutral, because that would have been the one sitting at the bottom, and the bottom of this is where the corrosion has happened. So basically the brush has just got seized in the little tube that it slides in and out, and the spring will always put pressure on the brush, forcing it against the commutator, the middle section of the motor. But in this instance here, the spring can't overcome the corrosion. So what I have to do is put plenty of WD-40 down it and keep trying to just work it up and down, and giving it little taps to try to free it up. Eventually it does come free, but it is very heavily corroded. But it's not a problem. We just clean that up, and once we get it cleaned up, at long last it is now sliding up and down in the tube very, very nicely. So it looks like in theory this fan should be working. So I'm just going to show you the brush nice and clean sliding up and down, and then we'll put it back together and we'll see if it's going to work.
Well, I think now that feels pretty smooth, because look, it's going to have to go all the way down to here, and even when we go all the way in, it's still there. There's still movement there. I think that's okay. So I'm going to give it one more wipe up, and then we'll pop it in and we'll see what's going to happen. Okay, we are on. Let's give that a spin. Right, so they're still spinning. Now, let's see if we have a resistance reading. Come on. Between these two wires. Please, please, please. Yes, come on. There we go, that's more like it. 15 ohms. Right, let's now see if that changes as we spin it. Hopefully it will stay. Well, there you go. It hasn't really changed, has it? It's between like 10 and 15 ohms. Let's go the other way. Excellent, well you can see that that's completely different to how it was earlier. So, while I've got this apart here, let me just get a wet wipe on the plastic bits and around here just to get rid of that. And then I think we'll plug it in again. So that's great news. According to the multimeter, it looks like this motor is now fixed. It's doing something different than before. And also it coincides with all the rust there. So the meter's showing no continuity and you can see that the brush was stuck. Now the brush isn't stuck anymore and the meter's showing continuity. So fantastic. It looks like this motor will work. I'm that confident that I give everything a good clean, not just the fan itself, but also the snow machine inside and out. And I put all the screws in because I'm certain at this stage that I fixed it. So I bring it outside. I can't do it now because it's midnight. So I go to bed, I wake up the next morning and we're going to pick up the video now where it's nice and bright. I've got it in the garden and we're ready for the big turn on. Will it work? What do you think? Yes or no?
Right, nervous times. So I've got my extension lead plugged into a breaker and obviously my house is already protected, so I'm hoping that's going to be okay. Right now we're off there. Let's plug it in, see what it's going to do. Here we go. Let's turn it on here to begin with. Right, it made that initial noise, so now we go over to the remote control. I'm quite excited. Might be one big letdown. Right, here we go. Here we go. On. Come on, do something. I'm going to put it up to max here. Well, that was an anticlimax. I don't think any fluids come through there. That's annoying. So, maybe it is sucking instead of pushing, you know what I mean? That's maybe it is polarity conscious because of the diode. So let me undo all the screws again and let me swap it over and let's see then if it starts pumping. Either that or the pump might have failed. I mean, I have been bashing it around the place, so maybe the pump's failed. That's a shame. Okay, I've swapped them round now so that the positive is on the edge and the negative is the one inside that. So let's see if that makes any difference, because maybe it was blowing through this side instead of blowing through this side. Okay, so let's try it now. I haven't put many screws back in because I just can't see how that would make a difference. But because it's just moving forward and backwards, isn't it, like that? So surely if it's moving forward and backwards, it should just be shoving the fluid through. So I think the pump is at fault. Right, let's see now. Are you going to work? Unless, of course, I'm not giving it enough time. Ready? No, I can't see any fluid coming up here whatsoever. It looks completely dry. So, fan's definitely working. We've definitely fixed that. But there's a problem with the pump. That's going to be very hard for me to fix. Okay, well, I'll take it apart one more time. Let's get the pump out and let's see if I don't know what to suggest. So I'm battling a couple of different things against that pump. I've taken it apart, so maybe with all my bashing and stuff, it's now not moving freely. But as well as that, I don't know which way it goes on the board. You know, does it make a difference? The diode is throwing me. Maybe the diode's there because it will only work one way. I'm not too sure. Well, look at this. I thought to myself, let's start on the board because we've already had this apart and it kind of looks okay, doesn't it? But just in case there's no power getting to these terminals, and I took a picture, undone them, and look here. We've got a lot of corrosion on that one there. But I mean, that one does go up to this like thing here. You know, the little DIN switch. But still, I don't think that's going to cause any problem. But it does need to be cleaned. So yeah, good job we did that. Let's take this over and see if we can like trace the wires back from here. Maybe, for example, that resistor's failed and it's not allowing power to the pump. And also we've got a little bit of corrosion there as well. But like I say, I don't think that's actually going to cause any problems. Let's go straight onto this resistor here. And let's see if we get any ohms reading from it, just in case it's blown. It does look a little bit discoloured, doesn't it? Well, you know, 50 ohm resistor, that could well be correct. So now, what have we got going on?
from here, I can see there's a trace going up here. We know the pump's not getting any voltage. And I was thinking it goes into the relay, but look, there's another trace in the middle here. And if we go here, you can hear it comes up. Yeah. And it goes to the neutral here. The blue wire is the neutral. And if I go to diode, this diode test is, this little diode is testing okay. So you can see there we've got a reading that way round. And if I go this way, we don't, it's open. So yeah, I'm just going to go through the board, see if I can see anything obvious. I now need to work out why we haven't got the live. What's going on here? Why have we not got voltage here? Power live goes into this thing here. Just want to see, is that a normal hole at the bottom? Yeah, it is, yeah. Right, so it comes into there. See, maybe this thing isn't switching properly. So this three-legged device that looks like some sort of transistory MOSFET thing is actually a triac, and a triac is used for driving things like AC motors. Apparently you can also get them in the old dimmer switches as well for incandescent bulbs. So at this stage of the video, what I do is I unsolder the triac because I want to see if it's testing what it's testing out of circuit. Also, the white chip next to it with 6 legs, that's actually an optocoupler. Now, we've tested those before in some recent videos. So that's basically like the isolation between the low voltage and the high voltage. So I unsolder that as well. This video has a lot of voiceovers because it was filmed over 3 or maybe even 4 days. I spent a lot of time on this, not full time, but on and off I spent a lot of time. Also, I unsoldered the 3 transistors. The beautiful thing about this board is everything is labelled up. Next to each resistor, it will say 1K, 4K, 4K7. And next to each diode, it will have a number. Even underneath the relay and stuff, there's a number. So it's labelled up everywhere, which is just fantastic. It's actually a dream to work on if I had the knowledge to do it. What's lacking here is my knowledge. Anyway, I unsoldered the 3 transistors as well. They're NPN transistors. And as far as I can see, everything seems to be testing okay. I don't know how to test a triac, but I'll show you that in a few minutes later on in the video. Let me just show you the testing of the transistors and also the optocoupler. Right, NPN transistor. So that one looks okay initially. NPN. NPN, that's annoying. Right, okay. Right, I think I'm nearly ready to give up on this. I can't find anything wrong with it. I've taken the optocoupler out. I've got a resistor on the LED side. So I've got right now 1.69 volts in. And if you have a look at my meter, you will see that we are getting a reading. You have a look there, 26,000 ohms. And let's go up to 2.2 volts. It was doing this earlier, but you can see that it's reading something different. Let's go up to 2.5. There you go, 19,000 ohms. And now let's go down to 0.9 of a volt. Let's see if that will give us anything. No, CC is not on. So that says to me that it's working. Let's go up to 1.45, see if that turns on. Yeah. There you go, 58,000 ohms. So I think the optocoupler is just fine. Now, this thing here, I don't know how to test it. It's got a gate, it's got like A1, A2. So obviously the gate is from the optocoupler. And then what it's supposed to do is, I presume, connect together A1 and A2. If I put it in here, and put it down, it is giving me a reading. It's just saying 2 resistors, but it is giving me a reading. Okay, hold on one second. It said 2 resistors earlier, bear with me. Right, why is it only saying that now? Well, that's really weird, but it was warm before. Interesting. That's giving me a different reading than it was before. But as I say, when I was heating it up, it took quite a bit of heat with the desolder station to get this out, so it was still warm. So that's reading different whether it's warm or cold. Do you know what? Let me order up a Triac and then see if that fixes it. You never know. Right, I'm going to try one more thing. If the Triac is just connecting, all we need it to do is basically connect A1 to A2, yeah? So if I was to short between A1 and A2, is that not the same as bypassing the gate and just allowing A1 to connect to A2 to make the circuit? So I'm going to try that, and then just to see if the pump starts working. Obviously then, if it does, it will mean that snow, in theory, it would work. It's just that you won't be able to control it with the remote control. But for me, I just want to see whether or not that pump comes to life. If it doesn't work, what's going to happen? See, all we're doing is connecting up that to, which will then allow the voltage to go through to the pump. I think that should be okay to do, just purely for testing. Right, let me just double check this now. Yeah, I've shorted out A1 and A2. So that should put the live from here, straight down to here, into the live terminal here. And we're already getting the neutral from here, which goes up the front here to this neutral wire up here. So in theory, that should just put, as soon as I turn it on, it should be put in, as soon as I turn the switch on at the back here, it should just be making this work straight away, shouldn't it? No matter what the circuit's doing. So let's see if it does start pumping through here. Right, what I'm going to do is, I'm not going to get the Guitar Hero out, I'll get a broom out, and I'm going to knock that switch on from well out of the way, because I don't feel safe whatsoever. Right, I'm plugging it in now, and turning the isolation transformer on. Right, okay, I'm going to get a broom. Right, okay, here goes. You probably won't even see the broom. Yes, you can see the broom. Right, I'm going on now. I can't get the broom. Right, even when I turn it off, I can hear the pump. I don't think it's sucking anything through. Right, I actually feel quite safe now. Right, so I can't tell if the pump's still working with the noise off the fan, but why is that not actually sucking? So you can really hear the noise off the pump. Would it make a difference which way round it is? Right, let me turn it off. What I'm going to do is I'm going to swap these wires around just in case, because nothing was coming through there, was it? It was making the noises, but nothing was coming through. Let's swap these round. Because we should see it going through here, shouldn't we? Unless, of course, you can't run them dry. Maybe you have to prime it somehow. Anyway, let's give it a go, see what happens backwards. Right, I'm going to turn it on again from a distance. Oh, interesting, it didn't kick off that time. That's interesting. Now let's do it. So the pump's not working that way round. Right, okay. Right, that's interesting. So, I wonder now, obviously it's not sucking, is it? So we've got no blockage there. I wonder, does it need to be primed? Right, obviously I'm unplugged at the moment. So I'm going to try to just see if I can actually kind of force any water in by pouring it in and then maybe even blowing it. Is that even going to go down or not? Yeah? It's very slow though, isn't it? How come that doesn't want to fill up the pipe? I'm just going to try to blow in it. I'm going to turn it on again. And to me that looks like it's full of liquid, because it doesn't seem to want to be filling up the pipe. So I think maybe it's full up to there. Let's just see. Right, turn it on again now. There we go. I've seen it shoot through. Can you see? Look here. It's working. It's working, look. And it's splattered out here. You can't see, look. Ah, right, pump is now working. Let's just see now, if we turn this on at the same time, will the fan and the pump work? Because it sounded like every time the fan kicked in, the pump stopped working. Whoa, 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 whoa. We've got snow all against my wall. We've got snow. Amazing. Right, okay, pump works. So obviously there's something on the circuit that's not working. Let me just clean up the mess I've just made. In fact, let me get you the camera just to show you the other camera. I didn't dream it would come out so quick. Splattered all against a wall. I thought it would take a while to, you know, to fill up, and you can see the snow there. Excellent, okay. I think what I'm going to do is, I'm going to mess around a little bit longer, because now we know the pump is working. It's just, it's not, I'm just still confused about the gate. This would be better for a live stream, because then people could help me. There's obviously something wrong on that DC side of the circuit, which is not telling that triac to turn on. So this is a perfect opportunity to test the triac with the multimeter, and then we will know for certain whether it's good or bad. I'm thinking it's bad, because when we bridge the pins together, then everything seems to be working. But yet, the gate of the triac may not be getting told to turn on. So the triac may not actually be faulty, even though it looks like the triac is at fault. Right, it's the next day now, and last night I ordered up a couple of triacs, because I thought to myself, we haven't got voltage here going to the pump, and this is the thing that controls the AC voltage, the triac, so I thought maybe this is faulty. But annoyingly, I've just looked up how to test them, and this isn't faulty. So it looks like I've ordered up two for no real reason. So with it we have A1, A2 and gate. This is A1, this is A2 and gate. And basically they're kind of like diodes back to back. They allow AC voltage between A1 and A2 and also A2 and A1 when you have, I believe, a positive or a negative voltage on the gates here. But the way to test it is you put your meter in into diode mode, so this one here, and basically if we go red to A1, black to A2, it should be open, and it is. If we swap the leads, it is still open. If we go to A1, black and gate, we should have a reading, which we do. And if we go A1, black, red and gate, we should also have a reading. Now, the next thing is to do with the gate, shorten the gate out. So if we were to go A1 red, A2 black, and then if we get tweezers and short out between the gate and A2, it should be, give us a reading. And now if we go between A1 and gate, it should be open. And if we swap the leads round, again, we should have a reading between gate and A2 when we short them out. Yeah, but between A1 and gate, we don't have a reading. I don't know if you can see any of that. But anyway, long and short of it is the triac is okay. So, yeah, that's annoying. I don't know what to do with this thing. I'm wondering now if it's this chip here that's failed. Okay, it's the following day again now. This fix is certainly dragging. I've been trying to get my head around the circuit and I have got news. Fingers crossed, good news. So let me just talk you through the circuit because I've been trying to understand it. So basically, we know that this side here, obviously I'm unplugged at the moment, this side here is the AC side. We know that this is going to be running from AC and this is going to be running from mains AC as well, these two. So the thing is, this side here is going to be DC because we need to allow the mains to switch on this relay, and also we need to allow this triac down here to switch as well to turn this on. So the relay to turn this on, switch to turn this on. So basically the mains comes over to here, and this is like just an old-fashioned linear transformer here, and it takes it from 240 volts or 220 volts there down to 12 volts, but it's still going to be AC, and we need DC to run this side here. So to convert it from AC to DC, it goes through a bridge rectifier. After the bridge rectifier, it then goes into this voltage regulator, but converts to 12 volts down to 5 volts. We do have 5 volts feeding the chip on the top right pin. And we also know the relay's working as well because the fan is kicking in. So basically, the only thing that's not working is this here. Yet we know it's working when we jumper the triac together, then this starts to work. So for some reason, the triac is not being told to turn on via the DC side of the circuit. So what I've been doing is, I've been following the DC side of the circuit. So well, not just the DC side, the AC side as well. Everything to do with this triac, I've been unsoldering and checking. And this board is lovely because absolutely everything is labeled up. So for example, if you find yourself a resistor, you will see it will say 1K. Next to it will say 2K. Everything's labeled up. Even the relay was labeled up underneath here. So what I did is, underneath the relay, I unsoldered this. This is all sealed. I thought there might be water damage underneath that. It's not. It's perfect. This capacitor here is testing okay. The resistor that looks burnt above it is also testing okay. I've already taken out all the transistors. They're also part of the same circuit. And then I went up to this diode here. Didn't look too good. It looked a little bit sorry for itself. So I unsoldered that. Again, testing absolutely fine. So the only thing that was left was this little crystal here. The crystal to run the chip. And everything looked fine apart from the crystal. The crystal just had the legs ever so slightly corroded. The thing is though, they're quite far away from each other. So corrosion isn't going to have travelled between the two. But out of the whole board, the only thing that I've seen that doesn't look great, there's a few legs that look a little bit corroded, but yet the solder joints themselves look fine. But the crystal looked a little bit suspect. And you need the crystal, I presume, to run this chip. This chip here is an 8-bit microcontroller. So basically, I did all that and I thought I'm going to give up now because they all look fine. Soldered them all back in. And what I did is I just left this off here, and I leave these off now to show you. And all of a sudden, this came to life, and also I could control it using the actual remote control. So maybe what happened was, maybe this chip, because when we have this right the way down here, there's no fluid flowing through here at all. So maybe if the chip wasn't getting the right signals because of the crystal, it was always in like the off state there. But now when I turn it up, it is actually working. So yeah, well, I'll say working. It's doing something. I don't know whether it's going to produce any snow. I haven't tried it yet, but because I want to start filming to show you. But let me show you this bit here working. Right, check this out. So we're going to turn it on. Now, you can already see air bubbles moving. So look, if I turn it, oh, we're already on here, but sorry, that's off, that's on, yeah? Now, we are in the off state here, but look, if I start to turn it up very slightly, there you go. Right, okay. Now, this is happening on and off. It keeps cutting out, but this is the other thing that I wanted to explain. That's annoying. I thought that would give me enough just to show you it working. But have a look down here at my isolation transformer and look what it says. It says here, capacity 400 watts. Yeah. Now, look at the capacity of this. Snow Machine, 1200 watts. So that's why my isolation transformer keeps tripping, is because this is wanting to draw far more than 400 watts. It even looks like just on the little pump, it seems to want to draw more than that. So yeah, let me turn it on one more time to see if I can show you that pump working. So I've reset the isolation transformer on here. There you go. I mean, you can just see the bubbles moving now, so you can see it's doing something. Right, let's turn this on, and let's start to turn it up. There you go. Okay, that's all I can do because it keeps cutting out, but you've definitely seen it moving there. So now I'm going to put it roughly back together, do up a few screws to make it safe. Let's get it outside, see now at long last if it can produce snow. Oh, very apprehensive here, just purely because of the amount of work I put into it. I've also got a pine cone there, which for some reason is looking kind of Christmassy, so come on, let it snow. Christmas, good cheer, goodwill to all men and all that. Right, here we go. I'm going to plug it in. Now, excellent. Let's turn it on here. Oh. Hold on now, hold on. Let's get ourselves in position. If there's bubbles forming, I want to see it. Right, come on now, here we go. Let's get it on here. Let's crank it up. Oh my god, it's working. Oh my god. It's snowing. Amazing. Oh, it smells a bit. Look at that. Let's crank it right up. Oh, look at that. Oh my god, all that hard work paid off. I've got it on my lens, 1 second. How good is that? It comes out so quick, look at it. Obviously this, I don't know, I'm not sure if it's coming out in the camera lens, but there really is a flurry of it when you stand in it, but I'm not sure how well that's coming out kind of in the daytime in the camera lens. Wow, okay, so what was wrong with this? It was basically, obviously, water damaged, which seized up the motor. And in doing that as well, sorry, let me just clean that up there. In doing that as well, it also damaged the circuit board there. I fully understand why the motor wasn't working, because we could physically see that. What happened on the circuit board, I don't know. My guess is that it was the crystal, but that really is only a guess, because I took off about 6 components all at once, because I'd kind of given up, if I'm honest with you. So I think it was the crystal, but I don't know. All the joints looked, solder joints looked absolutely perfect everywhere, but that is the only thing I've done to make it work. So yeah, sorry, obviously, and the motor as well. Fantastic. Right, let's give it one more go. So I'm midway on this now. Look how quick it comes out. It looks so good. Look at it. Look at that. Right, well that is it for this video. If you enjoyed it, give it a massive thumbs up. Thank you so much, Liam, for letting me know about this and sending it over to me. And yeah, I hope you enjoyed it. Perseverance, we got there in the end. Take care, everyone. Apologies, I shouldn't be interrupting the last song. I love the sound of my voice too much. Now, unfortunately, because I had hours and hours of footage here, a lot of stuff got cut. One of the things that got cut was me explaining how maybe it tripped the electrics to begin with, because that was the first thing that happened to this when it was given to me. It tripped the electrics in the school. I think what happened was, we know that the motor has had a seized brush, didn't it? Normally those brushes are on springs, so they give a little bit in and out. I know they're to put pressure against it as the brush wears down, but also it probably allows the brush to put too much pressure on the motor, on the commutator. And I think because it was seized in position, it wasn't allowing the motor to spin very nicely. And I think it put too much strain on the motor, the same as having a stuck motor, even though it wasn't stuck. And I think that's what caused
the electrics to trip. Now, when I started testing it, the brush had probably worn away from just having a few starts where it was like seized up right against a commutator. Then I think it had worn away. And then because of the spinning commutator, I'm going to see how many times I can say commutator because it's a new word I learned. And I think that's why it was then open. You know, we weren't getting a resistance reading at all. So now it's back on the spring. It's allowing it to give a little bit. The brushes can give a little bit as the commutator spins rather than being solid against it. So I suppose there's less friction on the motor maybe. But you tell me what you think caused the original tripping off the electrics. Also, let me know what was the final fix on the circuit board. I know it was something to do with those last 5 or 6 components that I unsoldered. So, you know, the relay, the resistor, that capacitor, and also, I can't remember, a couple of diodes or something. But I think it was the crystal, because I don't think that chip was working. Again, I filmed it, but it didn't make the cut. That chip had 5 volts going into it. Top right hand pin was 5 volts, and I think the bottom left hand pin was ground. So although it had voltage going into the chip, if the crystal wasn't working, then it's not going to have the correct timing. So I think somehow the corrosion on the legs or something played havoc with the timing, and I don't think that chip was working. So it wasn't sending the signal through to the gates, because it all generated from that chip. I think it was not the bottom right pin, but the second pin up, or the second pin on the left at the very bottom. They were going down to the basis of the transistors, which were then going over to the optocouplers, which was then going over to the gate of the triac. So that's it. A really enjoyable video in the end, although it was a lot of hard work. Believe it or not, I did actually learn a thing or two, so I'm happy. Hope you enjoyed it too. I'll see you soon, everyone. Thanks for watching.